Hello, and welcome to the Data Engineering Podcast, the show about modern data management. Data migrations are brutal. They drag on for months, sometimes years, burning through resources and crushing team morale. Datafold's AI-powered migration agent changes all that. Their unique combination of AI code translation and automated data validation has helped companies complete migrations up to 10 times faster than manual approaches. And they're so confident in their solution, they'll actually guarantee your timeline in writing. Ready to turn your year-long migration into weeks? Visit dataengineeringpodcast.com/datafolds today for the details. Your host is Tobias Macy, and today I'm interviewing Viktor Kessler about architectural patterns in the Lakehouse that are unlocked by a fast and feature-rich Iceberg catalog. So, Viktor, can you start by introducing yourself?
Absolutely. Well, first of all, Tobias, thank you for inviting me to your podcast and giving the opportunity to talk about the lake houses, icebergs, and all that stuff. But yeah, maybe just a couple of words of myself. So my name is Viktor. I'm based out of Germany, and I'm one of the co-founder of startup Vakmo, and we developed very cool technology named LakeKeeper, but more details on that one. Well, from a background, maybe just to give you some idea, I do have a computer science background, and I spent around like 10 years building data warehouses. And I guess some people don't even know what is a data warehouse nowadays. So everyone knows about data lake and lake houses, but it's where I started. And from my career, I was in a financial industry, but the last career stops where I was at MongoDB, I was at Dremio. So all the time used to work with data.
And do you remember how you first got started working in data?
Oh, yeah, absolutely. I actually was even in my study, and like I'm in Germany, and one of my jobs or like internship was at SAP. And when I was at SAP, I got some data, and well, believe me or not, my instrument, my BI tool was Microsoft Excel and Microsoft Access, and that's how I started, just to crunch some data to prepare some KPI metrics for projects.
Well, there have been a few different anecdotal statements that I've heard over the years that the most widely used programming language is Excel, so you're in good company.
Absolutely. Visual Basic for VBA is a quite interesting language. Yeah.
Digging now into LakeKeeper and what you're building and some of the story behind that, I'm wondering if you can just give a summary about what it is and why you decided that it was a project that you wanted to invest in.
Well, first of all, Lakekeeper is an open source project on a GitHub, and let me maybe start with that idea of an open source, and everyone who listens just want to motivate to become a contributor of open source. And like, contribution is not just about to write a code. You can just go to GitHub, search for Lakekeeper, for instance, and just test it, give us a feedback, and like, give us a star. That's the easiest way how to contribute. But back to the Lakekeeper. Lakekeeper is an open source Apache 2.0 licensed software. And Lakekeeper is a Apache Iceberg REST catalog written in Rust. That's quite interesting as well. And it's super easy just to use it in order to build a lakehouse, because like, if you want to build a lakehouse, you need three main components. The first one is storage. So you can go to Amazon, you can go to Google or Azure. The second component of Lakehouse is compute. So you can use either Iceberg, Spark, you can use Dremio, Presto, you can use Starburst, Trino. And the third component is a catalog, because what we have here, we have a table format, Apache Iceberg. And in order to create a table and in order to manage the life cycle, you need a catalog. It's unfortunately a misused word, catalog, but in essence, what we have here is something what we know from a database, like information schema, and that's something what we built in the first place, so everyone now can actually build a lakehouse.
Digging more into that element of the catalog that, as you said, has been part of database architecture since databases were created, and in the data lake, data lakehouse ecosystem, the predominant manifestation of that has been the Hive metastore, basically as an accident of history, because it was something that was there, everybody just kept using it. and adding to it as the Hadoop ecosystem grew and expanded and eventually fizzled out. But the Metastore stayed. And in the past, I'd say 2 years, there's been a lot of renewed interest in that catalog ecosystem and the different types of features, the use cases for the catalog as a standalone component, both within the Lakehouse and also now more broadly in this expanding ecosystem of data assets as they grow to encompass unstructured data, AI models, et cetera, et cetera. And I'm wondering what you see as some of the main motivating forces that have led to that renewed focus and renewed energy around the catalog as an actual product in and of itself.
Yeah, so it's quite a lot of stuff happened in a last couple of years, you know. Well, the first thing, maybe even to start before Hadoop and Hive, if you look at a classical data warehouse, so you had your Oracle, your Postgres, and it was quite easy and comfortable just to go in and create some data warehouse core and data marts and store the data. But then Hadoop happened or came by, and what we've got is that we started actually to decompose that monolithical system, what we know like from a classical database. Like my co-founder Christian is explaining that if you will take a Thor hammer and you will just hit the database and that will fall apart, you will get like first of all a storage. It's what we have like with HDFS or with Amazon S3. The second part would be probably like Oplock or Lock of a database, which what we know like as a Kafka messaging system, NATS messaging system, lot of different messaging systems. Then the third part of that composition, I would say, is a compute, and it's why we've got Spark, Python, we got Trino, Presto, all the different compute engines. And as of now, right now, we see a lot of innovation in that space as well. So if you look at Polaris, Data Fusion, DuckDB, a lot of compute happening here as well. And the last piece was the catalog. And, you know, like when we started with Hadoop, we started to decompose the monolith and we've got actually Hive Metastore. And as you just described, like, okay, we have something which gave us a opportunity or possibility to manage the table state, the metadata of a table, because table consists like of two main components of a metadata and of data itself. And we had our catalog Hive Metastore as a facade, which we could use to manage the table. Unfortunately, the main focus was always on the data and almost less on metadata. And therefore, if you look at the Hive Metastore and everyone who played around the metadata, it was not that kind of crucial and main thing. The main point was always like, okay, let's look at the data. So someone was on a website, so let's send him an email. Or he opened the email, let's send him a discount. So, you know, like the whole actionability was on the data. And if you look at the metadata, it's stuck in the past. It was more like necessity. Or let's go and just type the information about who is the owner of that table. And it was like John Doe was owner of the table. And if someone was like asking, we need to make a change to that table, let's go to the John and ask him about that table. Where's the John? Well, John left company for 2 years, so no one knows who manages that table anymore. And at the same time, we have kind of a challenge even today with ownership, with governance, with quality, outdated statistics, outdated results. So every challenge what we actually have is more related to the metadata. And that was kind of a trigger where the community was more concentrating how to solve the metadata, how to solve that all the problems, and the solution is in the metadata, and especially to become the metadata actionable as the data itself. And the quite interesting thing, if you look at the past, like, okay, databases, we had information schema, very rigid, bureaucratic, very hard to do any stuff. Then we got the Hadoop ecosystem with Hive Metastore, very flexible, but kind of chaotic, so really hard to manage the quality and ownership. And now we have kind of a new player, a Lakehouse, with Apache Iceberg as a table format. And exactly that is a promise of Iceberg and a Lakehouse, that we can actually get to the place and to the point where the metadata will become actionable and the data will be actionable. But the question of how to make the metadata actionable is the responsibility of a catalog. And now we're getting like to the catalogs of Apache Iceberg. And there are multiple different ways of catalogs. So, like we started even with Hive Metastore, but the evolution of Iceberg catalogs get to the REST catalog. And LakeKeeper is REST catalog, which has very cool features about how to make the metadata actionable.
Another challenging aspect of the naming of all of this, both in terms of catalog and the metadata management, is that there's been a lot of overload in terms of that concept of a data catalog, where there is the catalog within the database engine and the compute layer, and the fact that the compute engine needs to have that catalog in place to be able to find the data to operate on and execute queries against. But there was also, and there still is, but for a few years, particularly around 2019 to 2022, there was a lot of activity around data catalogs as a higher order product focused on cataloging all of the data that you have across your entire data ecosystem, including tables, but also including files in S3 or data models or various other database engines. So cataloging across the entire set of technologies that you're using, not constrained within a particular technology or set of technologies. And I think that that has also led to a lot of confusion around when you say catalog, which type of catalog are you referring to and what is the purpose of it? So in this context, we're talking about the catalog in the database, but then somebody might also have a catalog such as an Atlan or an open metadata for everything across that, including what's in your REST catalog, and wondering how that has muddied the waters for somebody who is building that more focused and targeted catalog technology.
Yeah, you just described my kind of a usual day. Like I'm just starting to explain what we actually develop and what we do, and then or is it something like open metadata or like Apache Atlas or whatever? And no, guys, we have like a different focus. Unfortunately, the name is catalog, but then yes, there is a different focus and more a technical focus, and especially on the technical metadata. The quite interesting thing is though that we started with Apache Iceberg and we started with a metadata of Apache Iceberg, but because catalog is in so central place, and especially if you look on compute, and you have like a write compute and you have read compute. So you have like Spark which writes to the table, and then you have Trino which will read from the table, and then you have optimized compute, because what you need to do is to optimize your Iceberg table like every hour, every day, in order to get the performance of that table. But if you look at that scenario, so you have your storage, you have your Amazon S3, and then you have like all the different computes on the left, something which writes to Iceberg, on the right, something what reads from Iceberg, and catalog is in the middle of that. And the question is like, okay, so if that's not an open metadata catalog, which just has a description about the metadata, but it's a catalog which actually allows me to govern the access. And the question is, usually in a large organizations, like every department has its own compute. So how to manage the access to that table? And the answer is actually inside of the metadata, because we able to manage the access. So inside of LakeKeeper, we implemented OpenFGA, so Open Fine-Grained Access Control. It's open source technology as well, which allows us to give access to a specific group, let's say marketing, who manages the customer table, and marketing will use Iceberg to write to the table. And then we have someone from sales, they're using Trino. So the Trino users will just only have access control to read the table. And inside of a catalog, we can just go and create the access through the metadata to that table specified on the groups, and give specific access control to those groups. And just to finalize my kind of idea and an explanation for customers about the catalogs, right now you have a Lakehouse catalog for Apache Iceberg, and LakeKeeper can manage your access. But then we have all the data scientists, and they just want to use like LLMs, and they would like to actually to access the volumes where you don't have an Iceberg table, but maybe you have just PDFs or images, and you would like actually to run your model training on top of that data. And the question is from customers, okay, now we manage the access for metadata, and why not just to extend the catalog, such like LakeKeeper? So LakeKeeper will manage access for AI objects as well, through volumes, metadata. And that's something how we extend actually the idea of catalog, and that is like an additional thing how to explain. We started with LakeKeeper with Apache Iceberg, but the future will go beyond the Apache Iceberg, but all motivated by the metadata to provide access control, for instance.
The focus on Iceberg as well brings up the broader question too of cataloging across table formats, where some of the most notable ones in the tabular data set are Hoodie and Delta Lake. But now there's also additional options. Maybe one of the more notable ones is the Lance table format, which is a sort of a superset of what Iceberg offers, with the inclusion of vectors as a data type and some changes in terms of how it manages inserts and updates in the table structure. And there are a few others that are escaping my memory at the moment. And I'm curious, I guess, what are some of the opportunities for maybe not consolidation in terms of the tables, but being able to agree upon the interfaces for the catalog to be able to manage operations across table formats as well, for being able to act as that unifying layer across compute engines and table formats.
It's quite interesting to think about that topic. Like right now we have like the three main table formats: Iceberg, Delta, and Hoodie, and we can argue like which one is more popular, which one is more performance, which one is more used by engineers, and so on and so forth. And then we have like all that innovation because someone is not satisfied with Iceberg or with Delta, and they're just starting to do some additional stuff because the community, either of Iceberg or other communities, are too slow. And that's kind of the thing about the open source, that there is a very sometimes bureaucratic process to get new features. The thing is, I would like to maybe go to my kind of a previous job as a solutions architect, and you need to ask like two questions. If someone is just starting to do something and developing and making the innovation, you need to ask like, so what? So what is the business impact on that feature? And then it will be more understandable why some format will be more used by industry. And the answer on so what on Iceberg is quite clear, because the adoption is very great, and especially for the REST catalog, the adoption got very, very easy. So everyone is just to need to adopt the REST specification, and then you can read and write to Iceberg. And that's why you see, as of now, a lot of implementation based on Iceberg Java. We are trying to contribute to Iceberg REST. And I know like DuckDB is now working on REST catalog implementation as well, so they have already PR. And therefore, Iceberg is quite well positioned, and I would say dominates the scene, but I'm biased a little bit, I would say. But still, the thing is, if Iceberg is not capable to answer some business challenges and is too slow to implement it, at the end, someone will implement it and maybe create a new project, which will end up in new table format. And then the question is how easy to adapt that new table format. So you mentioned a couple of them, and I think if that new table format will bring a lot of new business opportunities, so business now can make a faster decision, or maybe we will go to the AI agent times and operators times where Iceberg is not sufficient and we need to do something else, then that new format will be adopted as well. But as long the question is, so what is not answered, and who cares about that new technology is not answered as well, it will be kind of difficult to adopt that new format. And as of now, Iceberg, I would say, implements a lot of new stuff, especially around streaming and then kind of real or near real time capabilities. And if you look at the Spike B3 and every new innovation around Iceberg, so I would say we can actually answer a lot of data related challenges with Iceberg, but not all of them. So we still have some kind of thing around embeddings, and I have discussions, for instance, with vector databases, and I understood that they actually, well, they started similar like data warehouse in a way of monolithical approaches where compute and storage of data is all tied together. But right now they experience same challenges, that they need to split compute and data. So they will probably go similar way, or maybe Iceberg can answer the challenge for vector databases, so they can adapt that as well. And it might that we're going to end with a new format, or it might that we're going to have like Iceberg 2.0 for warehouse, for analytics, and for AI.
Spending a little bit more time on the current competitive ecosystem of the catalog space, probably the two most widely marketed, at least, options in the ecosystem right now come from the two behemoths in the space, Snowflake and Databricks. So Snowflake has their Polaris catalog, Databricks released their Unity catalog, and in that overall space of catalogs and the ecosystem around it, what do you see as the main categories of differentiation that the different players are aiming for, and the opportunities for innovation and feature addition at the catalog layer?
Yeah. So the idea of Unity was initially a Delta table support and to support Databricks ecosystem. So right now we're opening that catalog for the community as well. So it's CNCF, or it's Linux foundation, which takes care of Unity right now, and the focus is still towards the compute engine, right? So that Databricks can provide the best way how you can read and write to, well, at the moment Delta, and I know that Iceberg is just about to start. So I think in around June, July, when Databricks has its own conference, we're going to announce that support for Iceberg reading and writing. And still, it's all about how to use compute and your catalog, and especially how to manage the access to the data. And I know that Unity looks towards AI as well, so they provide the access for volumes. So if you have any AI use cases, you can actually use Unity. But the best integration is, from my understanding, is if you're inside of Databricks ecosystem. On the other hand, we have Polaris with Snowflake, and here similar story without focus on Delta. So we like from scratch. Polaris started with Iceberg, and here's kind of a similar story that Polaris is well supported as a managed catalog inside of a Snowflake. So you can actually go and then you don't need to think about how to operate Polaris. You will just get the managed service provided by Snowflake. But again, here is the best integration if you're inside of Snowflake ecosystem. And that's kind of like the corner point. So if you're inside of ecosystem of Databricks, inside of Snowflake, inside of Amazon, for instance, because Glue Catalog provides that as well, I would say that you can become a very happy customer because everything is integrated. The truth is that if you go to enterprises, you will actually find the whole zoo of possible tools: Databricks, Snowflake, Amazon. It's multi-cloud, it's hybrid cloud with on-premise. And the challenge of CIO is how to manage that zoo. Like everyone is happy, and like someone is not hurting someone, because the ultimate goal of that organization is to make money, right? So that organization needs to be successful. So and getting back to that kind of poor person, CEO, CISO of that organization, they need to manage all of that. And what we want to just provide from our perspective is that become more agnostic. So, and if catalog is a central piece, so maybe you need some kind of a way that is not tied to any compute engine, not tied to any, let's say, ideology of compute engine, like, oh, we use Spark, and we use maybe not Spark, we use something different. And that's the main difference what I see from a C-level and from management level, that they need to make a decision how they're gonna do that, because there is a difference about where you store your data, how you like read and write your data, and how you manage your data. Because for managing of data, you need the metadata, and that's the thing of a catalog. Again, maybe I'm biased, and I am biased. What I see, there are plenty of different REST catalogs for Iceberg, who just not concentrating on a specific compute engine technology, like it's like ours, LakeKeeper, then there's Apache Gravitino as well. So the idea is a bit different, like, okay, we want to create a catalog for every compute engine. So you can actually go and use DuckDB, and you don't need like any big compute maybe at all. The thing is, if you look at us, at like more neutral player or agnostic players of catalogs, the direction is less on compute engine, but more on the metadata. And there are a lot of innovation around the metadata, which we had not in the last 20 years, probably. And that's the main differentiator. If you look at pure catalog players, the DNA is a metadata. And if you look at the catalogs which are tied to any compute engine, the DNA is data. And that's kind of a main difference, that you have like metadata companies and you have data companies.
Spending a bit more time on authorization, security, authentication, you mentioned that LakeKeeper is integrating with OpenFGA for being able to give that granular control. But more broadly, as far as the integration up and down the stack of authentication and authorization, that's something that I have personally run into numerous places in numerous technologies, of being able to manage that and let the different pieces of the tech stack know about where that authorization is happening. Because, for instance, if you're using Iceberg with AWS Glue, or with LakeKeeper with Trino as compute and Superset as the BI layer, every one of those things has its own ideas about permission and where it comes from and who owns it and what is the appropriate layer at which to apply those permissions. And I'm wondering what you're seeing as the capability of the pieces that are higher up the stack from LakeKeeper to be able to understand and reflect those permissions without just throwing obscure errors that lead to days of debugging as to why can't I do this thing that I thought I should be able to do?
Yeah, absolutely. Like the thing is, again, so why we end up in that situation that everyone has an opinion, like every tool has an opinion about the authentication and authorization, is because we started to decompose the monolith. So before that, we had like our Postgres, and then they had the user on the Postgres, and everyone was happy, and then that worked. But then we started to decompose that monolith. Everyone started to build the tool, and business was asking, okay, how about the authentication and authorization? And it's how we end up that in every tool, you will go and you will find some kind of implementation about how to give an access to an object. So right now, like as pendulum goes into one direction, now it goes in a different direction. So what we need to understand is the computation and storage can be decentralized, and they can use massive parallel processing and everything. But there are components which need to be centralized. And the authorization is one of those components. So you need some kind of a way that you have like on a central place where you can just say that Tobias can go and write to customer table, and Viktor can go and read the customer table. And you don't want to end up like, okay, so in Superset I can set that setting, and maybe I can go to Trino, but what about Spark and Iceberg? So you will end up like that you will have somewhere in your ecosystem inside of your company kind of a hole that someone will go and read your data or manipulate your data without like that you have control of that. And then that's something what we need to avoid like to 100%. There is a single system which authenticates someone, and that system is IDP, so like Entra ID, Okta, Auth0, Keycloak. I don't know, there are a lot of different systems, but it's a single system in a whole organization which holds the identity of a person of principle, and it can issue the identity like token, for instance, right? So we are all. And on a second thing is about how to access that specific object. And since catalog, the REST catalog of Apache Iceberg, manages the metadata, and everyone needs to go to the catalog to ask where is the data. That's the one logical place where you can actually put the information. If someone is asking for the customer table, let's ask, who are you actually? So are you Tobias or Viktor? And then the catalog will actually make a decision if you can do that specific operation, what you're asking the permissions for, or where table location is actually. And the quite interesting thing, what we developed with Trino and LakeKeeper, we took the next mechanism to OpenFGA. We took the Open Policy Agent, and we built a bridge which allows you actually to use Trino as a multi-user system, where Trino will provide the information to LakeKeeper that we know that you as Tobias trying to read the table, And then Lakekeeper will look inside of OpenFGA, what is your permission state, and will actually make a decision that you can read the table. So to put that all together, you have like Amazon S3 storage where Parquet file, the part of Iceberg table, is stored. Then we have Lakekeeper, which manages the metadata of that Iceberg table. Next to Lakekeeper is OpenFGA. So again, it's not built inside of Lakekeeper, but it's very close to Lakekeeper. And actually, you can actually take and replace OpenFGA through LDAP or I don't know, like Ranger maybe. There are different ways how to manage that authorization information. But right now we have OpenFGA. And then there is an OPA, like Open Policy Agent, which connects to Trino and to Lakekeeper. And then if you run your select statement from from superset, we will understand who is running that query through a whole setup, and which means you can actually build the Lakehouse for open source technology stack without spending any licenses at the moment, and you will actually get the enterprise ready secured system for multi-user usage of your enterprise.
So, digging more into Lakekeeper itself, you mentioned that it's built on Rust. You mentioned some of the ecosystem that it's integrating with as far as OpenFGA, Open Policy Agent, the compute layers. Can you describe a bit more about the design and implementation of Lakekeeper itself and some of the ways that that design and the goals of the project have evolved from when you first started working on it?
Yeah, that's quite interesting because we started almost for a year, and the idea was, okay, we want to build a lake house, and we need a lake house for our platform. And at that time, you can actually go and use Tabular. So we made a decision that this is going to be a core component of our platform. So we need to actually to build our own catalog. And we don't want to use Hive Metastore or anything on those. And the question was like, in which language we're going to build that? Because, like if you look at Iceberg Java is very mature. You can use it right away and build your catalog. So it's super fast to implement a catalog based on Java. But from our understanding and from requirements, what we estimated that this is a very crucial piece of infrastructure, of data infrastructure, and to get like the most possible performance and stability, we decided to use Rust, and Rust is kind of known for especially for that, right? So if you need something robust, then you will use Rust. So we started to build our catalog in Rust, and we made a decision to make that as far as possible modular. So which means if you look inside of our code, you will find like a lot of stuff is modular. So there's a part which is required for Iceberg, then there's a part which is for authorization, and right now the implementation for OpenFGA. We made a decision that the store of the data is going to be stored inside of Postgres, but it's again easy to change, because right now we use SQLX, and then you can go and build something like MySQL or like different dialect. So it's super easy just to adjust for that. Or if you want to use MongoDB, so it would be not a kind of a big change that you need to rebuild the whole catalog. It's just a module what you need to implement inside of Lakekeeper. And that's kind of a design of a Lakekeeper. And the additional thing what we decided at the beginning, that it shouldn't be only for a cloud, like as a service, but everyone who is like trying to manage its own environment through Kubernetes, we wanted to support that as well. And if you look at the support of Kubernetes inside of Lakekeeper, it's super integrated. I would say it natively runs inside of Kubernetes. We provide Helm chart. There is a Kubernetes operator as well, and we have even the integration with Kubernetes IDP. So for operator, we can actually go and then create warehouses, create a namespace, and all that different stuff. So just to sum it up, if you run your environment with your Kubernetes, so vanilla Kubernetes, AKS, EKS, all the different Kuberneteses outside, you can just take Helm chart, deploy it. You can use Kubernetes operator if you want to be completely autark, or you can use like some RDS from Amazon as well, and just deploy Lakekeeper. And it will take you like 5 minutes to deploy the Lakekeeper. And the plan is in the future to provide software as a service as well. But right now we have a lot of proof of concepts and production clusters on Kubernetes.
For people who have already invested in building out a set of tables, they have an existing catalog, whether that's Glue or Hive Metastore or some other REST implementation, what does the migration path look like? Or maybe they have a bunch of Iceberg tables and no catalog. And I'm just wondering how you are thinking about the onboarding and the adoption process and some of the ways that you've worked to make that as smooth as possible.
Well, the first question would be if it's required to migrate. So if someone is on AWS Glue, you don't need to migrate to any catalog maybe. So because if you all integrate it, it's all is good. You can just use AWS Glue. The thing is getting more tricky if somehow your management made a decision go to multi-cloud because like the price negotiation with a cloud hyperscaler is not that easy, and management is usually tending like to say, okay, now we have Google or now we have Microsoft just as a second provider. Then it is like, okay, we need to think about especially that part, and then there's a reason why you will migrate from AWS Glue, for instance. But usually you don't need to migrate at all. On Hive Metastore is might be different because if you look at the community of Hive Metastore, that it's not that active anymore as it was, and on maybe some vulnerabilities on the Hive Metastore, and there's a reason to migrate. And it's quite easy to migrate if you're already on Iceberg, because everything what we need is to migrate the metadata. The data can remain inside of your object storage. We're just about to implement the HDFS support as well. So for everyone who is on Hive Metastore with HDFS, they actually cannot move easily to Iceberg, like because Iceberg was intended to support object storages, but we're just thinking about to support HDFS. So if you're on HDFS and you would like to use a modern catalog, then you can go to LakeKeeper. And there is a lot of tools. So if you're not able to find it, just reach out to us or go to our Discord channel and ask us so we can provide you a migration script, which is going to mainly read the Hive Metastore metadata, go to LakeKeeper register API, and register that table. That's it. It's quite trickier if you're on Hive Metastore and you have like CSV, JSON, or Parquet-based table. That's something what will require more work because you need somehow to migrate your table, and especially we need to look at your ETL job. So for instance, if you use like Spark or NiFi or whatever. By the way, NiFi dropped support for a Hive Metastore in 2.0 version or something like that. So you need to take action in any case. But in that situation, you will need probably to make kind of a more migration from a data perspective as well. So you need just to go and then copy the data and rebuild your ETL in order to write to Iceberg. But that will give you a lot of advantages. I mean, that is something what you need to invest at the beginning. But through Iceberg, through compaction, vacuuming, like optimizing of a table, you will get way more advantages. And especially if I look at the Parquet-based or CSV or JSON-based tables, and that you need to metadata refreshes and reconciliation over schemas and all that stuff. So it's all gone because you use just a table. Therefore, there is a easy way with Iceberg. There is a bit harder way if you don't use Iceberg. So it's very depending on the situation of every use case.
On that point of table maintenance, compaction, vacuuming, I'm wondering what your thoughts are on the role of the catalog versus other tools. I'm thinking in particular about the new S3 tables functionality offered by Amazon and just where that maintenance is best managed.
Well, I can argue that there is a catalog which can manage that in the future. So right now, none of the catalog can manage that. So the feedback from customers and then like companies, what I have is that they need to manage that by themselves, like have a huge Spark cluster, because it depends like how you make a optimization of a table. So there are like 5 tasks for optimization of Iceberg table, 4 of them just based on the metadata. So we're going to build that pretty soon inside of the catalog. So you don't need to take care of that as well. The hard part is the compaction. So, like if you have some kind of a streaming job, which writes every 5 minutes, you will end up with a huge amount of small files. And what you need to do is to go and let's say you write 1,000 files a day, each is like 1 MB. It's better just to go and compact that to like 4 files, every one 264, 56 MB. So you will end up with that 4 files, because it's not just about performance, but what everyone forgets. For every file, you will go to Amazon S3 and you will make a getter list. It will cost you money, and it's very expensive at the end of the day if you don't do compaction. But again, if you don't do compaction and like you have money, but the performance will suffer a lot if you will just go like from Trino and you will just try to read the table. So a lot of IO needs to go down and read like every file. So it's why you need to make a compaction. And the answer today is like, okay, Catalog cannot do that. So you will probably go and use some external engine. So you can use Spark, you can use Trino to do the compaction. What we think that it would be super easy, and that kind of a feedback, what I got so far. And guys, like if someone listens, give me feedback as well, that it would be cool if I can just go into Catalog to the table and say, please make an optimization of that table like every hour or every day or once a week. And inside of the Catalog, we can actually achieve that. And we're thinking to implement the compaction based on the Rust with Apache Data Fusion. And it's way more efficient compared to the GVM-based way of a compaction, which will again save you money and time on your resources, on your cloud costs. And you don't need to think about that, because inside of the Catalog we track every change, and we probably can end up even with autonomous compaction for you. So we can just understand, is something happening on that table? We can understand what's going on, what type of queries you run, because Catalog can provide through Scan API as well the way how to access the data. So if we have all that information, which again is a metadata information, and then Catalog can actually optimize your table based on your real requirement, then the Catalog is from my perspective, is the best place to organize the optimization compaction of a table.
And for people who migrate to LakeKeeper, they're using the REST catalog. They get the advantages of the granular permissions, some of the optimizations that you're working on implementing. What are some of the ways that moving from, for instance, Hive Metastore or AWS Glue changes or adds to the workflow that they have for working with their Iceberg tables, some of the new capabilities that it unlocks?
Well, the first thing is that if they use REST catalog today and they will move to LakeKeeper, there is no much effort. So there is no huge change or whatever. They don't need to change actually a lot. They will just replace the URL and maybe kind of a credential stuff, and everything should just run as it was. But the question is like, okay, what will I get to if I will move to LakeKeeper? And like we built a quite interesting feature inside of LakeKeeper, what we call change events. So which means every time you will run, let's say, alter table or like whatever type of a metadata change, we can push that change out of a LakeKeeper in a messaging queue, in Kafka or in Nuts. And you can build all that reactivity based on the metadata. It's how we think that the metadata can become actionable, because if that's somewhere in a queue, we can actually take some kind of action on that. And the thing what we built is what we call an actionable data contract. And to explain you the idea behind that, so imagine I'm the owner of a table, so I'm a data producer, and let's call that table a customer table. And you, Tobias, you need that table. You need to build a report on that table because you will go to your management and you will make a decision on that table because you need to make an investment decision. You probably want to sell something, and so on and so forth. So what we see in every enterprise, that the data producer and data consumer, they usually don't know each other, and they don't know like that you rely on that table, on that data every day. And what data producers usually do, they have like the way that they need to change the tables. And what I can do, I can just go and make them drop filter, alter table, alter schema. So I can just do some changes which will break your report. So which means you have a business impact. And if you look, then you cannot make a decision. You cannot make a business decision. So you're not able actually to increase your revenue, or you're not able to make cost reduction, whatever different targets on your business side could be. And the idea is through that change event mechanism to build a contract where you and I It's not just a PDF or kind of a wiki page contract, but you and I, we will just go and assign a contract where you will tell me that you use my table like every day and you need a stable schema. And that is an SLO, that's an objective. That table schema should remain in place. And that is going to be like a computational unit stored inside of a contract engine. And what LakeKeeper can do, if I will run the older table, LakeKeeper will communicate first of all with OpenFGA, and OpenFGA will tell LakeKeeper, yeah, Viktor is an owner of that table, so he can do that change. But on a second step, LakeKeeper will communicate with a contract engine and ask, okay, do we have some kind of a business constraint here on that table? And that contract engine will tell LakeKeeper, yeah, Tobias has an SLO stable schema, so you cannot change that table. So I will get a conflict. At the end of that operation, you and I will be informed that there's a change probably in the future. And what I can do, I can go and churn the contract. So you will probably get like a grace period, 7 days, let's say. So you can go and change your report. But the main idea of all that contracting thing is to build the unbreakable consumption pipeline. So you can rely on the report, you can make your business decision. We need to do everything in order to keep your business process just intact. That's not going to be broken by someone.
In your work of building LakeKeeper, working with the ecosystem of storage and compute and consumers and data ingest, what are some of the most interesting or innovative or unexpected ways that you've seen the LakeKeeper capabilities applied?
Well, first of all, what we see is a contribution. So, for instance, like Kubernetes operator was contributed, and that was very surprising that people are just wanna do stuff, and then they are very happy to contribute. But the last thing, or just about probably to happen pretty soon, is that one of from a community offered to build DuckDB per Wasm inside of a LakeKeeper, and I am quite interested on that one because like what you have nowadays, like a very powerful laptop or notebooks on every desktop, right? So you can just imagine you have like 1632 gig of RAM, and so if you look at the last research of like how large is usual query. So it's usually like, I don't know, like maybe a gig or something, or not even that. And that's quite interesting to see that inside of a LakeKeeper UI, you will just open like an SQL editor, which will use per Wasm and DuckDB. And then you can actually go through REST catalog and make your queries. And that is, which will make your local computer like a query engine. So you don't need like a query engine at all. And that's intriguing idea that you can manage a lot of your queries on your local computer without having any big query engine in a backend somewhere.
Yeah, the ability to expand the possible set of compute and execution environments is definitely very interesting. And one of the things that I like about the Iceberg ecosystem and the fact that it is growing and evolving to include so many different computation paradigms.
Absolutely.
And in your work of building LakeKeeper and releasing it as open source, working on building a commercial entity around it, what are some of the most interesting or unexpected or challenging lessons that you've learned in the process?
The challenging thing was about Iceberg Rust and like Rust in general. So it's still very popular and very cool, but somehow I have a feeling that it's not that adapted as Java or like JavaScript or Visual Basic or Excel, and that was kind of a challenge for us to see that that ecosystem is still under development. So we needed to invest ourselves a lot inside of Iceberg Rust. But right now, if you look at Iceberg Rust, you see how Iceberg Rust evolves and getting even more popular and mature. So I see there is even the kind of discussion why not to build Iceberg Rust and then develop a client for like PyIceberg or C++ or like all the different languages. So it might even become like a central piece, which will then serve all other different languages, and just you can create your client for a specific language. Yeah, and that's something from a technical perspective, but maybe to give you like a business challenge, what I see is, well, first of all, it's hard to explain what type of catalog we develop, but I already mentioned that, and still I see that there is a lot of tools, and there is a lot of different technologies out there. So I think if you look at the customer, and let's maybe move from a catalog to the compute engines. So if I would be a customer today, so I don't even know how to pick a compute because there are so many, right? So starting from like Spark, Iceberg, going to Trino, Presto, then you have Starox, you have Rising Wave, you have DataBand, you have Polars, you have Data Fusion, and just Data Fusion has, I don't know, like 100 different compute engines implementation. So it's super hard for the customer, and I think that is kind of a main challenge in our time to explain or to give a reference architecture like, okay, that's how you're going to start. It's not going to cost you $1 million at the beginning, so it's probably not cost you at all from a licenses perspective. Everything what you need is an infrastructure. So go and get some EC2 machines. And then let's start and build that stuff. So, and the second lessons learned, what I give and talk to customers, there is no a silver bullet, and there is no like, oh, that's the solution. You can go like to a big one, Databricks, Snowflake. You will end up that, well, everyone, like what we say in Germany, cook with water. And so they cook with water as well. And at the end of the day, you will probably end up where those solutions are not sufficient. They're maybe too slow, maybe too costly. And what I learned is that data is a specific thing, and we need to be more, well, data aware, and use all that different tools, and then just like experiment and not trying to plan for the next 5 years. That was like just this week I had a conversation like, oh, we have a plan for the next 5 years, and I'm like, oh, that's gonna be hard because in the next 5 years we will have like all the different type of technologies. So what you're gonna plan today is already obsolete probably in a 6 months, and that's something what companies need to adjust themselves. Like the companies needs to become more startup like. Yeah.
And you've addressed this a little bit already, but what are the cases where LakeKeeper is the wrong choice?
Well, first of all, if you all integrate it in a solution, so I would probably not recommend you to use a Lakekeeper or like any different catalogs outside of your ecosystem. If that is the case, but it's usually not the case. The not a good choice is if you have like a Delta table, so we don't support Delta at least for now, and therefore I wouldn't say like use Lakekeeper. And Lakekeeper catalog is not a good solution if you want to build something like what Open Metadata provides. So it's a different type of solution. So we can collect a lot of metadata, but that's not a business type of a metadata. What business would expect usually, and you can actually run the Lakekeeper, create a table, and there is a tab row. You can open that tab row, and you can see what type of metadata I'm actually talking about, and that's a super different stuff compared to a business metadata. Yeah.
As you continue to build and grow and evolve the capabilities of LakeKeeper, what are some of the things you have planned for the near to medium term, or any particular projects or problem areas you're excited to explore?
So the first one is I already mentioned the HDFS support. I was asked a lot of time to support that one because still a lot of customers on HDFS. The second thing what we still considering is how to help customers on Hive Metastore with a non-Iceberg table. And there are different ways how we can achieve that, maybe to provide some kind of a partial Hive Metastore API, so you can actually communicate through Lakekeeper to your CSV stuff. So that's the thing in order to replace completely Hive Metastore. But more interesting is that we have been asked about the central access governance for Iceberg tables and AI. So it's why we started to build something around the volumes, because what you need to end up is some sort of a similar mechanism what you probably know from a Delta share, and they're thinking about like to provide something like Lake share or Lakehouse share, and that will allow you actually to create a just single catalog and manage the whole access for both for data and for AI. And the last thing what I would like to mention is that what we would like to do is we would like to kind of connect that two silos, a data silo and AI silo for the metadata. So just to give an example, if your ML model somehow depends on the Iceberg table, so nowadays you actually have no idea if something is going to change inside of Iceberg table. And I'm not just talking about the new data, but if structure of your data has changed, you have like new data type or whatever, so you probably need to rerun your model training. And that's something what we would like to build inside of Lakekeeper as well. So the silo data and silo AI needs to be connected, and we truly believe that metadata level is exactly the way how to achieve that.
Are there any other aspects of the work that you're doing on LakeKeeper, the overall ecosystem of Iceberg and REST catalogs, or data lake catalogs in general that we didn't discuss yet that you'd like to cover before we close out the show?
The last thing what I would like to say here is, as I opened about the open source, guys, just really would love to motivate you to become a contributor. Think about all that great things what we've got in the last, I don't know, like couple 20 years around the open source. That open source is a real innovator. So everyone who somehow connected to open source, and I'm just talking like to everyone, even a developer, if you have some contributor level, PMC level, it will boost your career. It will help the community. It will help to everyone. So it's a win-win situation. So please go to a project. LakeKeeper is one of them, but there are different projects as well, like Apache Iceberg. Go test them out, write a new documentation, read the documentation. You will definitely find a spelling bug. Open VPR, start the Git repo. It's what I would like just to mention here.
All right. Well, for anybody who wants to get in touch with you and follow along with the work that you and your team are doing on LakeKeeper, I'll have you add your preferred contact information to the show notes. And as the final question, I'd like to get your perspective on what you see as being the biggest gap in the technology or tooling that's available for data management today.
Yeah, like that's quite interesting because I do have kind of a lot of discussions with business people. And, like if you go to inside of a company and you will see usually like 100 people, so 10 people understand all the data management thing, but 90 they don't understand. And what I see as a gap is how we can actually explain them or maybe make a connection to the business process to the data management. And I think there is a solution on the technical side, which we don't have at the moment. And I hope that we're going to develop something that's like everyone in the organization understands how data can drive revenue or how data can help the organization to be more successful.
Well, thank you very much for taking the time today to join me and share the work that you and your team are doing on LakeKeeper. It's a very interesting project. It's great to see the innovation and investment in that space. I definitely look forward to seeing how it progresses and watching it grow. So thank you for taking the time and energy to help move that ecosystem forward and expand on its capabilities. And I hope you enjoy the rest of your day.
Thank you, Tobias. Thank you for everyone who listens. Bye.
Thank you for listening, and don't forget to check out our other shows. Podcast.net covers the Python language, its community, and the innovative ways it is being used. And the AI Engineering Podcast is your guide to the fast-moving world of building AI systems. Visit the site to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story.
And to help other people find the show, please leave a review on Apple Podcasts and tell your friends and coworkers.